Welcome back everyone to this next part in the Watch Me Build series. Just to very quickly recap, in the previous session we started putting down a basic A2A server implemented in Go. We also discussed the different transports supported by the A2A protocol, and we decided on implementing our agent using the gRPC transport specifically. And because we were implementing it by gRPC, that meant we needed to bring in the protobuf definitions from the official A2A project. So we took the .proto files, we compiled the protobuf definitions, we pulled them into our project, and we then had to register a basic gRPC server and register the actual A2A service on the server. And then we got to the point of needing to start implementing the different RPCs on that A2A server interface in order to start engaging with the agent. We started with the basic GetAgentCard RPC method, as that's obviously the entry point for any user or client wanting to make use of this agent to figure out what it is about, who it's from, what it can do for you, etc. Since the last time, I've just actually made some minor modifications to our agent card, just formally specifying the transport as the gRPC. And then something which we didn't actually mention last time was just defining the skills for this particular agent. So in sticking with just the theme of just a simple weather agent, the skills are effectively what is this agent capable of doing, or what is the things that it's good at. And so we've just registered a simple skill on this agent, basically the ability to generate a very simple weather report. And the nice thing about the skills definition, over and above just giving it an ID and a name, you can describe what the skill is about and also just give examples of the types of things that this agent can help you with. So for example, a good type of a question that you'd expect this agent to be able to work with would be, what is the weather today in New York or wherever you are. So I think we'll use that then as the sort of segue in today's session. There are quite a number of other fields on the agent card, but we'll get back to those when and if we need them. And I think for now, we'll move away from the agent card and start moving into the actual RPC methods that we can use to interact and send requests to the particular agent. So just going back to the actual proto definition source of truth, we have these two core methods, the send message and send streaming message. So these are the two RPCs that one would use when engaging with this particular agent in order to make some request. So the first send message RPC, as they describe here, is a blocking call. So it will you send the request, the agent will do some work, you wait for it to finish, and when it's finished you'll get a response, and then you'll get sort of that completed task or a task with some action like input required or something from the user. So it's sort of synchronous blocking, wait for something. The send streaming version of it is you send your request and the agent starts its work exactly in the same way as this method, but instead of having to effectively be blocked until you get into some state where there's action required or the task is completed, the agent can emit events, update events along the way, so that the client can stay updated as to what progress is being made on the particular task or what the agent's doing. The send message is obviously just the simpler version of the two. We'll definitely be implementing both of these, but I think for today if we can get to a simple version of a send message RPC implementation, then I think that'll be a good place to get to for today's session. So if we just go back to our server, So what is required here is to actually now register or implement the interface for this new RPC method. So it is the send message. It takes in a send message request and a send message response. So if we just to make our life a bit easier, here, we're just going to copy that across. So it's a send message. So that's the name of the RPC. It is a send message request, and it returns a send message response, right? And then just so the linting is happy here, pb8a dot. So we would return a pb8a dot send response and no error in the ideal world, and the payload, and we're going to do a task, but we'll get to that. Okay. So we've got the basic skeleton for this RPC. So this is where to implement the magic, right? Before we start getting into that, let's just actually set up this testing method for ourselves. So let's just call it send message, and the request is a send message, and let's say again a send message. So change this here. Send message. Okay, and now so just forget about metadata and configuration for now. That's not too relevant. We'll eventually get to what those are for. So let's just populate a message. All right. Okay, so just going to jump back to this again. So if we look at the send message request, what are we expecting here? So this is just the send message request expects some configuration and metadata, which we said we're just going to ignore for now, and then it takes in a message. So a message is the sort of unit of communication across the A2A protocol. So if we just look at the message definition, so any message has got an ID, it's got a context ID. Again, we'll get to sort of what the relevant of the context is, but you can think of that almost like a session. So like a collection of messages that follow from one another. For example, it's got optionally a task ID attached to it. If this message forms part of an active task, it's got a role, so who's the actual person responsible for the message, sort of in a multi-turn conversation. Is it the agent or model that's responsible for having generated this message? Is it the user that sent this and provided this message? And then again, some metadata and extensions, which not relevant for now. And then we have this content, and content is a set of parts. So a part is just the sort of simplest simple sort of container unit for information that you'd want to communicate in a message. So for example, there are 3 different part types supported by the A2A protocol. There's the string part, so text part, so it's just a plain string, so it's just for text that you're wanting to send your message. There's a data part and a file part. We'll look at those sort of in later as and when they become relevant. File part, as the name suggests, would be for communicate if you're wanting to sort of send files like, I don't know, PDFs or some bytes to some content, maybe an image or something like that. And then data parts are relevant for sending things like, for example, like a JSON object, sort of more structured data that you're wanting to send as part of a message. But for now, we're just going to be sending through a text-based input to our model. So let's just, before we get into the implementation, let's just set up, what we actually want to do in terms of sending our request to the agent. So we've got this weather agent. We want to ask it something about the weather, like, what is the weather today in placeholder in my city, wherever one is living. So an incoming message would have an ID. So let's just give this just a unique ID. Doesn't really matter too much. Context ID, task ID, we're going to leave blank for now, so that's not too relevant. In terms of the role, the role of the message, it's the user, because we are now going to ask the agent. From the perspective of the agent, we are the user or client interfacing with it, so we are the user role. And then now we specify our parts. So we said there's obviously different types of parts that are supported. We are just going to support the text part, and this is where we're going to send our message to the agent. So what is the weather today? I'm in London, so I'm going to ask what is the weather today in London. So this is effectively our request to the agent, and this is what would be sent to our .SendMessage RPC, which would then execute the logic that's sitting here, right? Okay, so I think then we've effectively set up for the what we want to be requesting from this agent, but at the moment the agent can do nothing with it. It's just going to return an empty container shell with nothing in it. So in order to make this agent, or allow this agent to do anything, we need to hook it up to a large language model, LLM. In our case, we're going to be using Gemini, and more specifically the Google Gemini Go SDK. So we're not using any framework to implement this agent. We're just going to be using the raw SDK to interface with Gemini. So I think let's just start setting this up. So Go have this convenient internal reserved word. You can create folders, and effectively allows you to separate your application into sort of smaller packages. So that's going to be just a nice way to just separate our actual business logic from our sort of client setup, which is just like utility workflow. And so we've got a clients folder now, and so let's just create a new file, and we'll call this client. New file. We'll call this clients. Let's just call it GenAI.go, because it's just our GenAI client, and we'll give this it's a new package. It's client package. Okay, so the first thing we need to do is import the google.golang.org/GenAI. So this is the Golang SDK, so this is what we're using to interface with Gemini. And then we want to just create a variable that will be exposed by this package to our top level application, and this will hold the GenAI client. So we just store that here, and then when our application starts, we want to actually initialize this client. So we're going to put our initialization logic here. So this will just be initialize the client. All right, so let's just set up a few things. So we're going to need a context. So we just grab our background context. Probably you're going to be useful to have an error variable. So let's just create that. Okay, so now we need to create our client. So using the GenAI Go SDK, so we can create a new client that takes in a context and takes in a configuration for our client. So most of these configurations are not necessarily useful, relevant right now. Okay, location is going to be. So we're not going to be working with an API key. We're interacting with Gemini via a Google Cloud project through Vertex AI. So we don't have an API key. So we're therefore going to use the GenAI Vertex AI backend. In terms of which project, so in my local env file, I've got reference to a project, so the Alice OS project is just a convention on the Alice build platform. And then location wise, I'm sitting in London at the moment, so I'm just going to connect to Europe West 1. And of course, we just want to just check for errors, any errors, establishing our connection with the client, and we're just going to again use our logging package to just log out any issues when we try to create our client. Right. There. Okay. So now we've got an initialized Gemini or GenAI client. So now now that we've got that in this nice little package here, we can start bringing that up into our top level application. So if the way to do that, we just need to import it. So it's just the name of the actual module that we're in, with the internal, and then clients. Let me just call that package clients. Let's just call it package clients. Okay. And right, so now we've got this guy. Okay, import and not use, that's fine, we're going to use it. And okay, so now we can actually go and interact. Well, now we can go and make a call to Gemini. So interacting with the Gemini SDK, we get a response for Gemini. This was an error that we need to handle for. And now we can use our client that we set up. So clients.genai, so this is the sort of object that the client object we exported. And then we want to models.generate content. We're just going to use the synchronous version. And then we need to just inspect this method. So we need a context, we need to specify which model we want, we need to provide the GenAI content, and then the configuration, okay? So we provide the context. So this is just our incoming context. We're going to just be using, I think, Gemini 2.5 Flash, be more than good enough. We need to specify it's an array of GenAI content. So we'll specify that and populate that soon. So we need that, and okay, what we haven't got the GenAI imported here, so google.golang.org/GenAI. So that's now happy. We'll get to that in a second, and then the last thing we need is the configuration. Okay, so we just need to now populate. Okay, let's just handle our error. If error not equal to null, return that error. Okay, so we've got all that now, right? Okay, now I'm going to quickly just create a task ID and a context ID. We'll get to in later sessions sort of on proper management and creation of these things, but for now I'm just going to create just a very simplified task ID and context ID. So let's just do that. Okay, and I just need to import this UUID package, so it's github.com/google/UUID. Okay. Right, so we've got a task ID. Yeah, just sort of bear with me on this. We'll get to more formal where these things come from and where they should be created, and etc. Right, so our incoming message, as you recall, there's no task ID or context ID present here. So what we're going to do, again, this is just simplifying things. Our incoming request, we're just going to set the task ID to this simple task ID that we created, just to effectively mimic the fact that we are creating a task. The agent is creating a task in order to process this request from the user. So we're just, in a very simple way, setting task and context IDs onto the incoming request. Okay, right, so that's that sorted. Now, in terms of the GenAI interacting with Gemini to actually now send the user request. So the user has sent this request, it's coming in as part of the request, and in the content, and it's a text part. Now, we're going to make a couple of assumptions here, just to simplify things, but let's just take a look first at what this content looks like. So the content requires two things. There's parts and role. Now, the role is the user, so that's, well, you know what, we can actually role user, we can define that more safely. And then in terms of the parts, we're now not dealing with A2A parts, we are dealing with Gemini GenAI SDK parts. So the Gemini SDK parts that it describes is the parts that you require in order to interact with Gemini. The parts for A2A are the parts that A2A facilitates as a protocol. So those parts are completely independent of the parts defined by Gemini. They're sort of two separate lenses. But what we do need is effectively then a way to take the A2A part that's coming in and provide it to Gemini in a part that it understands. Now, I said we're going to make some simplifications to make this easy. I know in this case that our content coming in, we're only sending a single part, and I know it's of type text. So I'm not going to bother with checking, what type of parts and how many are coming in. I'm just going to make the simplification, or the assumption at least, that it's just a single part and it's of type text coming in. So from the perspective of what I need to populate this with, I know that I've got my request coming in. I know I can get my content, right? So this is just mirroring on the right-hand side, and I know that consists of parts. So I'm going to take the first part, and I know that I'm just grabbing the text. So effectively, what's happening here is we're taking the incoming message via the A2A message, and we're just pushing that content into our request to Gemini, so that Gemini effectively, as the large language model behind this agent, will receive that instruction and then perform some action, right? So in terms of the configuration, so this is just how we configure the behavior of Gemini. For example, if we want to register tools, we want to set the system instructions, we want to control the output schemas and things like that, and the thinking configuration, all things we'll get to eventually. But for now, I'm really just going to simplify this a lot. We'll just keep the system instruction, candidate count, we'll just set that explicitly to 1. That's just basically that Gemini is only going to generate one outcome for us, one result. And we're not going to have tools or anything like that. I think maybe the one thing we'll set is response modalities. we'll just send that to text because we just want to deal with sort of text-based output, at least for now. Right, okay, so we've got that specified. Just want to swap this around, just a little bit more intuitive for me. Okay, so we've got our request coming in, we injecting it into Gemini. Gemini has got the ability then as a large language model to process and understand that request and to generate us the answer. Of course, we don't have any tools registered at this point, but we can nevertheless still send the response, the request to Gemini in this way. Okay, so Gemini then receives this request and generates an output. And again, to keep this really simple, we are just going to assume that the output from Gemini is effectively, in this case, the result for our task. So when we've artificially created this concept, well, this notion of a task ID here just to simplify things, but basically we're saying when the request comes in, Gemini or our agent has created this sort of concept, this container of task, which is a formal A2A concept. It's given that task or request to an LLM to process, and then once that processing is done and Gemini has an answer for us, it's going to communicate back to the user as a completed task. I have done what you've asked me to do, i.e. I've told you about what the weather is today in London. So what we want to just return here then to the user is effectively the completed task, right? So the task that we're completing has a task ID, so that's why we created that ID. We created a context ID, so we're populating that. And now what's also quite interesting with tasks is that they also have a status, right? So a status is effectively communicated at any given point in time, like what is the status of this task. For us, like having a really simple task, we're just going to put that task and consider that task completed once the LLM generates an output, right? If we were dealing with more complex tasks that perhaps required back and forth, etc., or go through a series of steps, this task might have been put into a different state, like input required or something like that. We would have a lot more like complex workflows around the LLM. For now, this is just very simple, not even agentic at this point. It's just really request, LLM processes, generates a result, completes a task. So what we're going to do is, we also just want to add a timestamp to the status, so the client knows when this task was actually last updated or marked as complete. And then one can optionally add a sort of update message alongside the completed task. I'm not going to do that for now, so just going to keep that empty as is. And then the question is, okay, now we have the output. Now, before I just complete this, I just want to actually quickly take a look at this. So this is effectively the example that we are mirroring on, well, very similar at least, on our gRPC server side. So we're using the synchronous version of the A2A protocol, and you see we're just sort of sending a message to the user. So we're the user. Here are our parts. We're sending a text type, and in this case, tell me a joke, and it comes with some message ID. In our case, it's just what is the weather, but otherwise pretty much identical. And you see that in response, so this is just a walkthrough of some common workflows in A2A on the documentation, and then in response, this is what we would expect to get back from the agent. So we see there's sort of a status here, completed. So that's represented here. We've got our completed status. There would optionally be a timestamp, which they haven't included here, but there's a context ID, there's an ID of the task. You see this kind task. So we've also returning a task here, and you see that what it includes here is the history of messages that have been exchanged up until this point for purposes of completing the task. So this is just, given that this is a very simple task, a user request comes in, generates a response as the output. There's the only sort of element that's relevant for the history is the incoming message that the user sent. So it's simple as just the request.get request, which is the A2A message that's come in, and we've populated the task ID and the context ID here, so we have that, right? And then the other aspect that we require here is the artifact. So in this case, the result, so artifacts typically capture or a container for the result and output of a task. So in our case, we just have a very simple text piece that is basically the result and output of this task. In this case, the joke. In our case, the actual answer to what the weather report of what today's weather is based on the city that we requested it for. So we'll just give it an artifact ID, so we can give this thing an ID if we want to. We can call this weather report. We don't need to give it a description, that's not necessary. And part. So the part now is where we actually want to provide the answer, the output of the model that it generated. So we're just going to quickly just populate the part here. We don't need any metadata, that's unnecessary. And yeah, we're just going to work with text part. So we're just going to assume the only thing that this model or the agent outputs as an artifact or result is the text. So the question is now, where does this text actually come from? Well, the text is the output of the LLM, because the LLM is what is the sort of the brain, the piece of reasoning intelligence within the agent. So it's the LLM that actually generated the text. So that's sitting in this response object. Again, we're going to make some just simplifying assumptions. We know that we've got a very basic setup here. This response, we've only asked for one candidate, so we can assume that, in this, when we inspect this response, it's just a single, there's just a single output or result that we need to consider. And we know that because we're only expecting response modalities of text type, we can just grab the text that's been responded with and dump it into here, because again, we're wanting to output text, and we know that we're going to be getting text from the model. So we can just go look at the candidates. So we know that we're only generating one candidate, so we can just look at the 0th element. We don't have to consider anything else. And everything's stored in the content, and within content there are parts. Again, just for simplifying, because this is a very simple case, we can be pretty sure that there will only be one part output, and that would be a text type. So we can just grab the text from the LLM output like that. So at this point, we've effectively got now our response to the client fully defined. So the users, again, just to sort of recap the flow, what we expect to happen here, user's going to send a request to the agent via A2A protocol through the .send message, asking them a question: what is the weather today in London? That's going to come through. We're going to attach a task and a context, and that should just simplify things. We've just sort of done simplified assumptions at this point that some concept of a task and context have been created, and so we inject those onto the incoming request message so we can link it to the particular context and task, and then we process that result through the LLM. So let's just process request via LLM Gemini, and then we just return a task response back to the user. So let's actually just then test whether this works. So we can just run our server, and then we can run this method and we see what the output is. So it's going to obviously take a bit of time because the request is being processed by the LLM. And there we go. So we have this output. So if you see the output, we've got our task ID. It's obviously a little bit tricky to read. Perhaps what we can do is we can actually just make this a little bit nicer. So let's just use the JSON package. We can maybe just print out some nicer JSON here. So let's just do this. So let's just say some pretty JSON. JSON.Marshall indent. So we can take the response and we just want to print it out with a little, just here looking a little bit nicer. If error not equal, just check for the error. Let's actually just stop this. I'll stop getting notifications. JSON.Marshall indent. Okay. And then we just want to print out the string of this prettier JSON. Okay, so let's actually just do that then. So we run the server. Okay, and then we're just going to run the same thing again. And then this time we should hopefully get a nicer output to look at. So there we go. So there we have the user sent a request to the agent, and the agent has come back with a task. The task is in a completed state. This is just showing in protobuf now, but the number 3 represents completed state. And it's generated an artifact for us, which is effectively the answer. So the weather today in London, partly cloudy, etc. Now, obviously, the fact that we haven't given the agent any tools or anything like that means this answer has just been generated from the LLM's knowledge. We haven't given the agent ability to look up, sort of connect to Google search or anything like that. So it's unlikely that this is actually correct information. It's just generated from its own knowledge. And so in the next session, I think what we'll start to do is start bringing in some tools and allow this agent to actually reach out, what it looks like to reach out to an actual API, so we can get some relevant information like for today and pass that back to the LLM and have our agent give us reliable and actually useful weather information. So yeah, I think we'll close the session out there today, and see you next time.